Guys, what's up and welcome back to another video of Geeked on Science. So as you can see today, we're going to be talking all about atoms and their composition. So before we get started, all I want to ask is that you watch till the end. So without further ado, let's get right on into it. So before we do anything, we have to understand what atoms are. That way we can understand how to decode them. So atoms are the building blocks of life. Everything around you and you yourself are made up of millions of them. For now, however, let's focus on the atoms and elements. The difference between an element and atom is that atoms make up elements. Elements, however, are found in a special place called the periodic table. This means that only one type of element has one type of atom, basically meaning that each element is only made up of one type of atom, meaning they have a specific atom type. This means that a silver atom with 47 protons cannot become a gold atom with 79 protons. This also means due to their quantum spin that all atoms are neutral, meaning they have zero charge or no charge. Also, now that we've decoded that, we can finally get started with talking about the nucleus. Now, the nucleus is in the center of the atom, and it has two very important particles that make sure all the mass is contained in its nucleus, the proton and the neutron. These two work together to make sure that all the mass is contained in the nucleus. So, where do you think the nucleus is? Right there. Now that we've decoded all about the nucleus, we can now decode the subatomic particles. Now, in a atom, there are actually three subatomic particles: protons, neutrons, and electrons. Protons are in the nucleus, neutrons are also in the nucleus, and electrons are in separate valence shells. If you've ever wondered, yes, all the things around you are made up of just a combination of those three subatomic particles in an atom. Now that we've decoded those three subatomic particles, let's focus more into each one of them and find out what makes them so special. So, first of all, the most important one, the proton. Protons are not only positively charged, however they can be found in the nucleus and also have a relative weight of 1. Now, relative weight just means that the exact weight is not given. Now, weight versus relative weight is another topic. However, all you need to know for now is that weight means that the exact given weight is given, the exact mass. However, relative weight is where that weight is not given. It's just around that area. Meaning, if I say a relative weight of 1, it could be anywhere from 1.75 or even 0.95. It could be anywhere from that's around the area of 1. Protons not only do that, however, they also make up what an atom is. If you have 79 protons, it's a gold atom, but even one less proton, and it's a completely different atom. So, now that we've done protons, we also need to know that protons are positively charged, meaning they repel. So how do they hold together the nucleus? Well, that's where the neutrons come in. The neutrons are subatomic particles without a charge. They make sure that the protons are held together. That means that they can be found in the nucleus along with the protons and have a relative weight of 1, which also proves my statement about the mass of the atom being in its nucleus because of the huge relative weights in the nucleus. Now, if you looked at an electron's relative weight, it wouldn't be as much. And speaking of electrons, why don't we learn about them? Electrons are negatively charged subatomic particles, and they're located in valence shells around the positively charged protons, which attract the electrons. Now, if you've ever noticed, electrons are in a circular orbit as directed by the arrow around the protons, and electrons have a relative weight of 0, meaning their weight isn't 0, but around it. This means that their weight is negligible when calculating the total weight of an atom. Because of how little it is, it won't really make a difference. Now that we've done that, before we can go on to electron configuration, we need to make a summary of all the things that we have learned in so far. Proton's location in the atom is nucleus. Charge is positive, and relative weight is not the exact one, but around that area is 1. Neutron's nucleus is the location in the nucleus. Charge is neutral, and relative weight is again 1. The electron's location in the atom is its valence shells, negative charge, and relative weight of 0. Now that we've tackled that, we can learn electron configuration. Now, if you've ever wondered electron configuration, this is just a way to say that electrons are arranged in a specific way through their valence shells. The first valence shell can hold 2 electrons, the second 8, the third 8, and then the earlier shells must be filled before the next shell can be occupied. Now let's look at 2 examples, neon and chlorine. Now, neon atoms have 10 electrons, and the electron configuration of neon is 2, 8. This would be stated as 2, 8. If you've noticed, the 2 electron shells are completely filled, but you won't need a third one because of the amount of electrons in neon. Now, on the other hand, if you look at chlorine, it has 17 electrons, but the electron configuration is 2, 8, 7. However, if you notice, the third shell only has 7, whereas it could have 8. This proves that 1 more electron could fit, meaning if you had to add a 4th shell for more electrons, the third shell would have to be filled before the 4th. Thank you so much for watching, guys. I really appreciate it. And if you watched till here, I only have one request, that you like, share, and subscribe this video. Thank you so much for watching once again, and I'll see you in the next one. Stay tuned.